Okay, so once again, we got a polynomial, 4 terms. And I'll start with the first one. It's just, well, it's just a times b, right? In fact, I'll do it below. And then I would show this as -4, so I'm going to show it as -2 times a times a. Again, I'm continuing through the whole polynomial right now just because I want to make sure that there's no common factors amongst all 4 terms. So the -6 will then become -2 times 3 times b. And then the 24 will be, I guess we may benefit from showing the factor tree here. But I would show that as 6 times 4. Some of you may do 12 times 2. But 6 would be 3 times 2, and then 4 would be 2 times 2. Okay, so there's our prime factorization of 24. And if you need to pull out a factor tree for any of the, especially the larger numbers, then do it, okay? But 24 ends up being 3 times 2 times 2 times 2 times the a. So do I see any common factors for all 4 terms? I do not, which means that I'm going to go straight into grouping these, okay? Now, like I said before, if you don't have a addition or subtraction symbol between, just put one. Usually it's an addition sign. Remember, the -6b became -2 times 3, so I have the minus sign accounted for with this -2. So now I'm looking for any common factors from each of the binomials separately, right? So I got this a, which is common with this one. So that means I don't see any of the common factors there, so I'm just going to yank out an a there. So what's left inside? Well, I got the b from the first term, and then the second term, -2 times 2 is -4, but also the a, the other a that was left over. Okay, so b minus 4a. It's kind of a weird one, but like I said, on the last one, now that I've factored this out and I got b minus 4a, I really expect to see a b minus 4a over here, okay? Otherwise, the factoring thing is just kind of a waste of time. Maybe it still is. All right, so what do I got here? I got, oh, see, right here in this binomial, we got a leading negative on this one. That means that I'm actually gonna give myself a couple negatives over here like this, okay? Because I do want to factor that out as a -2. If I don't do that, here, I'll show you what happens, okay? So let's take that back like, well, I do want that negative. Dang it, come on. I just don't want these ones. There we go. Okay, if I don't do that, then what's going to happen here is I'm going to factor out, and again, I'm doing this kind of wrong on purpose, but there's the 3 threes. There we go. So you could say, we're going to factor out 3s. But also, I mean, you could even say 2s, right? And say, well, that's a -1 right there. That'd be fine. So let's say we factored out a 2 and a 3. 2 times 3 would be +6, right? Well, what do you got left on the inside now is -1b. I'm just going to show that as -b. And then you'd have a positive 2 times 2 is 4, +4, and then the a there as well. So see how they're opposite signs. Positive b minus 4a, positive b negative 4a. I got -b plus 4a. And whether you notice it here or you notice it here, you need to factor out a negative because this leading, again, this coefficient for this binomial its leading coefficient was negative. Well, we got to yank that out as a negative, okay? So instead of that being a +6, I'm going to treat that as a -6, which is going to change the signs of both terms on the inside of that binomial there, okay? So now it's -4a. Oh, well, that's great because now they match. And the truth is you could have yanked out a negative and a -1 out of this parentheses and then change these two signs to match. We just need these binomials to match, right? Okay, so what do I got left? I got this common factor of b minus 4a to yank out from both terms. And then what do I got left? Well, I had the a here and then the -6. And then I don't see any, again, I'm just checking for any common factors, greatest common factors from either one of those binomials. I don't see any, so that looks like it will do.